So I'm gonna try to do TikTok and YouTube at the same time. I'm gonna work on some Unit 7 stuff. I'm still gonna take that Unit 6 test, but um, I at least wanted to try some of these and see how this goes. So here we go. Unit 7, differential equations, separable. These first four questions are just simple error analysis. So just going through each step and then seeing like, did the person get it right or wrong? And if so, where? So I'm gonna try to see if I can point out some mistakes. I think I might just end up working these out and then comparing my work to, it looks like Laura's work. So that's what I'm gonna try. And then we'll see how this goes. But okay, so let's see here. All right, so differential equations. Remember with these, a differential equation is an equation that already represents a derivative. So to get the solution, solutions look like y equals, remember. So essentially, more or less, we're just kind of trying to solve for y. So let's see if we can do this here. So I got xy plus 2x. And in order to get y by itself, I know that we got to separate. This is technically, this is the BC course, but this topic right here is AB. So yes and no to kind of answer your question, James. So we are trying to get y by itself, but notice how on the right side, my x's and y's are kind of like intermingled. I'm going to want to separate those first. And when I say separate, I just mean like get all the x terms on one side and get all the y terms to another side. So I'm going to try to do that. And I got their solution to my right. So I'm going to try to like do what I would normally do and compare it to what they did. So what I would do if I'm trying to separate is I would notice that both of these terms on the right, they do have an x in common. So I'm going to go ahead and factor that out first. And I'm going to make sure to try to do one step at a time too. So that would look like this. X times the quantity of y plus 2. And then from there, what I would do, it doesn't really have to be in this order, but I would multiply both sides by dx. And then I would divide by y plus 2. And then on their work, they didn't show specifically every step, but I'm going to still try and see. So if I were to multiply both sides by dx, I would get this. I would get dy equals x times the quantity of y plus 2 times dx. That is me just algebraically multiplying both sides by dx. And then I gotta divide. I'm gonna divide by y plus 2 on both sides. Because remember, I'm trying to get like the y terms on one side. And when I say y terms, that includes the dy too. So I'm gonna divide by y plus 2. That'll make it to where I don't have any y's on the right side. And then I'm gonna divide by y plus 2 on the left. Okay, how am I looking? I'm looking good. So from here, I want to, let's see, I'm gonna rewrite the left side like this, watch. Instead of saying dy over y plus 2, I'm gonna just say 1 over y plus 2 dy. And that's gonna equal x dx. Reason I like to do that is because remember, when we solve differential equations, what's good, Metro? Our whole goal is to try to get y by itself. So essentially I got to get rid of the dy and the dx. And in order to do that, I'm going to just I'm going to integrate both sides. And then once I do that, I will no longer have a dy nor will I have a dx. So let's see what they did. If y'all look at step 2, even though they wrote it a little bit differently, that's the exact same as what I have. So far we're good. To actually integrate the left side, appreciate those likes. I noticed that this is 1 over something, in which the integral of that is going to be natural log. That I do know. So I know I'm going to have natural log of, it should be the absolute value of y plus 2. Is that how they have it? Yeah. And then I think I found the actually, no, I didn't find the mistake. And let me do it the full way. I need to add C. And then on my left side, that's just reverse power rule. So that's x squared over 2. And then instead of, I am going to add C, but it's a different C. So if you notice, I put a CX and a CY. Did I run 2K? Did I? I don't even think I did, bro. Yeah, no, but I don't think anybody got on. But I'm super duper down to run tonight if you're down. But okay, so from here, let's see what it, because our step 3s are right at the same spot. Well, actually not yet, because I think I might have found a mistake in her work. Because if you look at step 3, anytime you integrate an indefinite integral, you need a plus C. And if you look at step 3's left side, they do not have a plus C. Because if you look on the right side, they got a plus C1. Now, I don't know if they added C to both sides and then subtract, like combine the C's, which would make sense. All right, I'm gonna just keep going because it's technically not wrong. So let's just keep going and then see what they get. So we got ln absolute value of y plus 2 equals x squared over 2. I'm subtracting cy from both sides, and cx minus cy is just some constant. So I'm just gonna call it c. You can collect your constants inside 1c. Yes. Cy and cx are both constants. So when I subtract cy, and I low-key, I probably should have showed what exactly I did. That's my bad. All I did was subtract cy from both sides. So if I were to show it correctly, it would look like this. And then cx minus cy is just some constant. So I just call it c. Yeah. So from there, let's see. I got a ln of y plus 2. I know that if I know Khan Academy might, like, it seems like they do it one way where they take e to the both sides. Me personally, appreciate that follow. What I personally do is if I have ln of something that I'm trying to isolate, like this y plus 2, I'll literally just take e to the power of the right side equals the y plus 2 in this case. And that is the same thing as what they're doing. So I don't even know if she made a mistake. Let's see. So this will be literally like this. It'll be y plus 2 equals. Now here's the potentially tricky part. It's going to be e to the power of this entire right side, which is x squared over 2 plus c. So my exponent is x squared over x squared over 2 plus c. And then the absolute value, if you know what natural log graphs look like, their inputs are only allowed to be positive. So in case anybody's wondering like where the absolute value bars went, we know that all inputs of natural log functions have to be positive. So there's no need for absolute value. But yeah, facts. I'm trying to do TikTok and YouTube at the same time, and I have yet to figure out how to do face cam for both. So if you want to see my face, it's on YouTube. But okay, so from here, let me see what they did. Step 6? Okay, from step 6 to step 7, what it looked like they did was they used this property right here. Do I have space? Yeah. Off to the side, I'm going to remind y'all of this property. I don't know if y'all knew this or not, but if I have like a to the n plus m power, like some base, and then my exponent is like the sum of two things, you can rewrite it like this. I don't know if y'all remember that from like algebra 1 or something. A to the n plus m is the same thing as a to the n times a to the m. A to the n times a to the m. Yes. Okay, not to be confused with. I know I'm only writing this because I've seen a lot of people do it. This is not to be confused with this right here. I've seen this mistake far too many times. Those are not the same thing. So I'm about to use that property. So that's why I brought that up. So this would really be y plus 2 equals. And then it's going to be what? E to the first term times e to the second term. So that'll look like e to the x squared over 2 times e to the power of c. All right. Yeah, exactly. So yes, Brom, you got it. E to the power of c is still some constant. So I'm going to write, instead of e to the c, I'm just going to write that as some constant and call it c. So really, we're looking like a y plus 2 equals. And then that e to the c, which is really just some constant, I'm going to put it in front. And then all I have left is the e to the x squared over 2. And then, of course, you can see that all I got to do is subtract 2 from both sides to get y by itself. And that, ladies and gentlemen, is exactly what her step 7 looks like. So if you ask me, I say she didn't make a mistake. I think we're good. So I'm gonna go her work is correct. Yeah. Let's go. Okay, that was correct. Is it general or particular solution? Okay, good question. This is general. And the reason I know it's a general solution is because we don't know the value of c. If I were to get the value of c, I would need like some type of initial condition at the beginning, which would make it a particular solution. So that is a good question. Okay, bet. All right, let's keep going. So I think all 4 of these questions are all like error analysis or like find the mistake type of question. But I'm gonna still work them out so y'all can still see how it goes. All right, so for this next question, they are asking what? So they start out with dy dx, and then it looks like they got to separate variables because there's x's and y's on both sides. So what I think I'm going to do first is, let's see, I would probably multiply by dx on both sides and divide by y on both sides. That is what I would do. So that is what I'm going to try to do. So we'll call this number 2. What they give us is dy dx equals what? 2y times cosine of x. Okay, it doesn't seem too crazy. Now I'm gonna try to do yeah, I'm gonna keep the 2 on the right side, even though I could put it on the left side if I wanted to. But I'm gonna try to do 2 steps in one. For one, I'm gonna divide by y on both sides, and then secondly, I'm gonna multiply by dx on both sides. So I'm gonna do both of those in this next step. So that should take me to look like this. It should be 1 over y, because remember I'm dividing by y. My dy is still there, equals. My 2 is still on the right side, so is my cosine of x. But remember, I'm multiplying by dx on both sides. So that's going to look like that. Variables have been separated, yes. Once I do that, I can proceed to try to get y by itself by integrating both sides. And fortunately, these are both very easy things to integrate. So let's just go ahead and do that real quick. So the left side's integral is just going to be the natural log of absolute value of y plus c sub y, or you can call it c1 and c2, whatever you want to call it. And then I'm going to say equals, and then I'm going to integrate the right side. The integral of cosine is going to be sine. And the only reason I know that is because the derivative of sine is cosine. So this right-hand side's integral is going to be 2 sine of x plus c sub x. Okay, from here, algebra. We're going to try to get y by itself. First, let's check their work. So step 1 looks good. Step 2, ooh, I noticed something. The only time they include their plus C is at the very end, which is not correct. Their plus C should be in step 2. At the very least, they should have a plus C on the right side. So step 1 is correct. Step 2 is incorrect. The right-handed side of the equation should be plus C. Like I said, I called it. Okay, so yes, that is correct. Okay, yeah, these ones are not that bad. All right, number 3. Okay, so boom, there's our differential equation. So separating this, I'm gonna try to just look and see what I need to do. So to separate, I would need to multiply by dx, and then I would need to also multiply by y squared. So let's, I was just talking about like not working it out, and then look at me now. So if I were to separate my variables, I would get on the left side, I would get what? Y squared dy. And then on the left side, if I were to multiply both sides by dx, I would have a 1/3 x to, I'm going to write it like this, x to the -2, because that x squared is on bottom, and then times by dx. And so I can see that they multiply both sides by 3, which is not incorrect. That is literally correct. So step 1, in my opinion, looks good. Variables have been separated properly. Step 2, it looks like they integrated. So if I go reverse power rule on the left side, can y'all see that? Yeah. So if I go reverse power rule, then that's 3 times y cubed over 3, which is just y cubed. 3 with the y is simpler because it's just power. Yeah, exactly. So I'm not mad at them for moving the 3 to the left. So that integral does become y cubed. And then the right side's integral, if I use reverse power rule, that'll be what? X to the -1 over -1, which is exactly what they have. They just simplified it. So then to get from step 2 to step 3, it looks like they took the cube root of both sides and they included the plus and minus. Okay. Okay, we know it's not B because she did integrate correctly. Step 3. They definitely added a plus C. Yeah, they added the plus C. Step 3, the right-hand side of the equation should be positive cubed root. It's either, yeah, I think, yeah, you know what? I think it's got to be D, because the plus and minus should only go in front of a square root, not a cube root. So I think it's D. Brahm, let me know. Do you agree? If you agree, I'm putting D. Let me know. Because you made a good point. If you're cube rooting, you should not have a plus or minus sign in front. So if you're still in here, give me the word and I'll check it. Usually when considering radicals, you only take the positive values unless it's minimals. Yeah. Yeah, I mean, I don't know. I do think the answer is D. I am curious. Let's just see what they say. Assuming that it is D. Okay, bet. So they said, what was their solution? Okay, it says unlike, see, okay, so we called it because we were saying that plus minus should only be in front of square roots and not cube roots. And right here, it says unlike with quadratic functions, which we would need to square root, Marcus should not use the operator when he is inverting the cube, the plus minus operator. Okay, so yeah. It is all because of a cube root and not a square root. Okay, bet. Let's go. All right, so this is number 4 out of 4. We're so smart. We are, man. Would you like to know Weather Boy? Who is Weather Boy? Put me on. I'm not sure who Weatherboy is. But okay, last one. dydx equals 6x minus 30. This one seems super easy. So, and actually this one is super easy because the variables are already, well, not already separated, but all we got to do is times by dx on both sides. And then if you wanted to, I think she made a mistake on step 1, low key. Because look, let me work this out to convince you that she made a mistake. So on number 4, if we start out with dy dx equals, what was it? 6x minus 30? 6x minus 30. If we were to separate variables, you don't think she made a mistake? Okay, let's see. Let's see. She might not have. Maybe I'm just going too fast. If she were to separate properly, that means she would need to multiply both sides by dx from here. From here. Notice that me adding 30 right now, it's mathematically it's possible, but me adding 30 would not help us separate variables. So let's see. Let's just see. If I were to multiply both sides by dx, I would have this right here. I would have dy equals this entire right side, which is 6x minus 30. I would take all of that and multiply it by dx. That is a mathematically correct rule. So, and you can actually integrate dy. Because when you're integrating the left side, you're actually not integrating nothing. Because integrating nothing means you're integrating 0. But what you're actually integrating, let me erase this arrow so you can see it. What this technically is think of it as a y to the power of 0. Which, I don't know if you remember, anything to the power of 0 is just 1. Exactly. So the derivative of y is 1. But remember, well, yeah. The derivative of y is 1. So the integral of 1 is exactly Brom. Bro, you know calculus well. Let's go. So from here, if I were to integrate both sides, so I think we can safely say that she made a mistake. I don't think we need to continue. Yeah, she didn't separate correctly. Yeah, I say B. Let's go. That one was kind of tricky, I'm not gonna lie. Brom, I appreciate you for sticking around, man. Okay, bet. Now, Brom, are you like, did you take calc already, or what's like, are you a student? What is your situation? Because I remember you joining earlier. But okay, let's see. Before we continue, I wanted to try to fix my webcam, but Calc 1. Oh, bet. Nice. Okay, well then these streams should be like of pretty good value to you. Calc 2 starts in a couple of days, so I'm not gonna lie. But all right, so now that was another. You skipped trig and they didn't let me kick. Oh yeah, nice. That's what's up. But okay, so here's the plan. I want to do this unit 6 test because look, check me out. I don't know how much of this you can see. Oh yeah, you should see a lot of that. If you look at my units 1 through 5, they're all complete, which looks good. However, if you look at unit 6, I need those to turn into purple crowns. Today is the goal. But problem is I haven't eaten. So I need to go do that because I need sustenance. So the plan is to go eat. I'm going to probably take my dog for a walk. And then I'm going to be back on here and on YouTube. So Brom, I'm still trying to like experiment with these streams in regards to like whether I go on TikTok or Twitch or YouTube. So I was just about to say, bro, give me a follow. And then if you can follow my YouTube too, because I might go on there. I'm going to try to do both at the same time, but just in case something goes wrong, you can find me on my YouTube. I appreciate it. But all right, man, I appreciate you sticking around. If you can enable notifications, that way you can see whenever I get back. But yeah, let's do this Unit 6 in a couple of minutes. So I'm signing off. Brom, I appreciate it. I'll catch you later. Okay, TikTok is done.